Alrighty, we're finishing up chapter 4. Like we have 5 or 6 slides left. 7 according to this. I'm staring at this slide and I don't see what they're trying to talk about. Make sure that if the sales code is not A or B, the customer gets a 10% discount. There's 2 ways of wording that. You could say if sales code not equal A and sales code not equal B. Yeah, okay, that's true. If not, sales code equals A or sales code equals B, then do that. And here's the part that mystifies me. Don't do this. If sales code is not equal to A or sales code is not equal to B, this expression can never be true. So what if it was A? Well, then this part's going to be false, but then this part's going to be true, right? Or sales code not equal to B. Looks like it's true to me. Or sales code not equal to B, so if it was equal to A, this part should be true. I'm really not getting why it says this expression can never be true. Well, we could copy and paste it. I'm not getting it. Y'all see that? Y'all, can y'all parse some sense out of that? Because I'm not getting it. Oh, I mean, we're supposed to be using and there, sure. I get that, but I still don't see why the expression can never be true. All right, now that I think about it, that's a true statement after all, but I'm still not getting why. The reason I'm saying that is there's a mathematical law, and I forget the name of it, that it says if you have this expression, not A and not B, you can rewrite that to say not A or B. Those are equivalent. Or if you have not A or not B, then you can rewrite that as not A and B. So since they want it to be this, if not A and not B, then if you rewrote it, it would be not A or B, like that. So these two are the same. That is the same as that. This is not the same, because this would be that. And I guess it's true that you could have a sales code that can't equal A and can't equal B. One of those is going to be false, or both of them. Right?
Yeah, both would have to be true for it to not work.
Yeah.
But
neither one.
B is the same thing.
Yeah.
Then it would always work.
Yeah. So what if it was C? That would be true. And then you OR it, and that would be true. To me, it looks like it would always be true. That no matter what, it's always going to be true. And it says it'll never be true. I think it'll always be true. But no matter what it is, if it's A, sure, then that's not true, but this is. If it's B, then this is true and this isn't. If it's a value that's neither A or B, then both of them are true. So it's true that don't do it this way, but it should say the expression can never be false. That would be the correct way of putting it. So this is a useful law to remember, and I don't know why semester to semester I never remember the name of it. But if you're going to take, it's kind of like if you have this, 3x plus 3y, and you're going to simplify it, or you're going to take that 3 out of it, then you get x plus y, right? Same business here, except when you move the not outside of it, you have to flip the operator from and to or from or to and. So you can just write it in whichever way makes more sense to you. If you feel like saying not equal A and not equal to B, that looks pretty good to me. I'd be real tempted to go with that. But if you feel like saying not sales code equals A or sales code equals B. Feel free. So decision making in graphical programs, making a decision within a method, is no different than making one anywhere else. True enough. You can use if else, switch in the same way. So GUI programs use controls to make decisions. The user can click on a button, which causes the event to fire. The user may have selected one of several different radio buttons, and then the button would check to see which radio button had been selected in order to which choice to execute. Or you can have a list box. A list box is just a series of choices, the same idea. You could check to see which choice they had selected. It'd be worth doing that. And here's their example. Patronage, movie rating, click on discount. And so we would get the age by converting it to text. We would get the rating by converting it to a character. Not sure why we wouldn't convert it to a string, but whichever. And then you could convert that to a message, whether the discount applies or full price based on the settings. If they are less than child age or they're greater than senior age, and also the rating is equal to G. So seniors and children get into G movies at a discount. So summary, a flowchart is a pictorial tool, great. If you can use an if statement, single alternative. You use if else if there's two alternatives. If there's more than two alternatives, you use if, else if, as many as you need. You should, if you have multiple alternatives, you should always have a final else at the end of all your if cascade. If, else if, and then there should be a final else. Even if it doesn't look like it'd ever be true, just as kind of an error handling case. Print a message, if nothing else. So and, both expressions, both operands have to be true on either side of it. On or, only one of them has to be true. One on one side or one on the other. And if both are true, so much the better. And has a higher precedence, just like multiplication has higher precedence. In switch, we played with switch. Tests a variable against a series of exact matches. So you have a switch followed by an expression, and then you have a bunch of cases underneath it. You know, case 1, case 2, case 3, and it'll jump to the right one. And then the conditional operator is used as an abbreviated version of if else. So you could say A is equal to, is B equal to 3? Question mark. If it is, set A equal to 7, else set it equal to 8. For whatever purposes. It's just like if else. If this is true, then copy the 7 over into A, and if it was false, copy the 8 over. Use the not operator to negate the result of any Boolean expression. So if the Boolean expression was true, then not would be false, and vice versa. Errors are common when making decisions. Okay, thanks for depressing us. You just have to check your logic. And decisions within GUI methods are just like decisions in console applications. True enough, right? You can use if statements and switch statements inside of a GUI method. No reason not to. It's still C# code. It's still going to support logic. On to chapter 5. Looping. Alrighty, I remember our last lecture involving loops. So why are we starting over fresh? Let's go look at our notes. Because I remember the homework was things like write a simple loop that'll do this, write a simple loop that'll do that. Am I wrong about that? Simple loops. So how far did we get? Lecture notes. Take a look. While lives is greater than 0, subtract 1 from lives. For I equals 0, I is less than max plus, I plus plus. Alright, so Creating loops using a while statement. I'm assuming at this point we know how to do that then. While condition, do a block of code. And if your block of code is a single line, you don't have to put the curly braces. In here, something had better change something so that the condition becomes false, or else it'll never leave the loop. Or you can use a while true as long as you have a break statement. A break will exit the loop. An infinite loop is one that never ends because its test condition never becomes false. I remember this statement now. The body of the loop must take, no wait, talk about infinite loops that might end due to computer memory and hardware capacities. True. It's not really infinite, right? Someday you're going to turn the computer off or kill the program or whatever. So the loop variable is initialized, it is tested, and the body must take some action that alters it. We have done this in classes in the past. You initialize a variable, you have a test while x is less than 10 or whatever. That's your test. This is your initialization. And then you have your body of your loop, and the body of the loop had also better have an update, like x++, something like that. If it doesn't have the init and the test and the update, it's not a classical loop like that. Something had better kick it out if that's the case. There better be some kind of if break in it if it's not going to get out any other way. So an empty body is a loop with no statements. That sounds like an infinite loop to me because nothing would ever change it to false. Right, if I did this, if x equals 7, well, if x was equal to 7, it would keep repeating endlessly. So an empty body sounds stupid to me. I'm not sure we have to have a slide over it. Incrementing is when you add to the loop variable, x++. And decrementing is when you subtract from it, x minus minus. So a definite loop is one where the number of iterations is predetermined for keep going from 1 to 10. I'd use a for loop for any definite loop. A counted loop, a definite loop. You know the number of iterations in advance so the program can know. I would use a for loop for it. An indefinite loop, the value of the loop control variable is not altered by arithmetic, but is instead altered by user input. So the user can enter a value that will cause it to quit. For example, the sit no value. The user has to type in a y to continue, or an n to stop the loop. So for loops are definite loops. You get to specify 3 things. You specify a starting point, and then you specify the condition, and then you specify the update. And I'm scrolling past that because we have talked about that on the last slide, and I bet y'all have all used for loops many, many times. So when a variable can be accessed, it is in scope. When a loop body ends, any declarations made within it are out of scope. So if you had this, while x is equal to 7, you created a new variable like that. Then by the time you got down to here and you tried to print out C, right, console.out.writeLine C, that would be an error because C is no longer defined once it exits the curly brace. If you needed to do that, you would need to declare C above the loop, and then it could modify it. When you're accumulating totals, that's how you do it. You create a total variable above the loop, and then you add to the total inside the body of the loop. Now, it's still an infinite loop because nothing is ever modifying x, but you get the idea. If you have a for loop, if you create the variables with the syntax of the for loop, like int x is equal to 0, x is less than 10, x plus plus, this variable is only in scope through the body of the loop. Once you get down here, if you try to print it out, console.out.writeLine, if you try to print out x, that would be an error. Again, if you want to access that when the variable is done, you could, but you'd have to declare it beforehand. That would be a valid way of getting a hold of it. Right, initialize it as some value, modify it in here, and then print it out. Now, if we did that, What is x going to equal? Just a little thought problem. We started off at 0. We keep running as long as it's less than 10. When is it going to loop? Exit the loop. Yeah, it's going to exit when it equals 10. And so if we printed it out, it would print out 10. If we change this to less than or equal to 10, what would it display? So when's it going to equal to exit the loop now? It's going to count from 1 up to and including 10. So by the time it leaves the loop, what is it equal to?
11.
Yeah, 11. And then the do loop is a post-test loop. The thing that is of interest of a do loop is that the body is always performed. It's not conditional. The condition comes at the end, which is why it's called a post-test loop. But the body is always executed at least one time. Like that. Loop body gets executed at least one time, and then the condition is checked. And if the condition is true, then it repeats the loop. Nested loops. You have an outer loop and an inner loop. And here we finally are to something new. The inner loop must be completely contained within the outer loop, and the loops can never overlap. Well, let's go to Visual Studio and play with that concept. That's how you work with two-dimensional arrays, by the way. So we'll hit this concept again pretty soon. New project. You know what you're doing at this point, I hope. It's a C# application, a console app. I believe we're on lecture Hij. J looks correct. So CS_lecture J. You don't have to add the CS. I just do it to differentiate it from my C++ class. So a nested loop. What if we wanted to print out every 15 minutes on the hour, starting from midnight, right? So 12:00, 12:15, 12:30, 12:45, and then 1, all the way up to 6 o'clock or 5:45. That's the range of numbers that we want to be able to print through. Well, we're going to use a nested loop. The outer loop is going to contain the hour. The inner loop is going to contain the minute. And this is definitely a definite loop, so why not use a for loop? So for, parentheses, int, I equals, what did I say we're going to start at? 12? No, I'm going to start it at 1 because I don't want to mess with that 12 rolling over to 1, right? So I'm changing my specs on me. I'm going to print out all the 15 minutes between 1 o'clock up to and not including 6 o'clock. So I is equal to 1, int I is equal to 1. I is less than 60, semicolon, I plus equals 15. I want to go up, no, wait, what am I doing? Go up to 6, up to and not including 6. So I less than 6, semicolon, I plus plus. Add 1 hour to it each time. And I'm going to change it from H, from I to hour. For hours equal to 1, hours less than 6, hour plus plus. Same for minute. For int space min equals, and we're going to start at 0 and add 15 to it each time. So int minute is equal to 0. Keep running as long as min is less than 60, or we could change it to min less than equal to 45. I'm going to go ahead and go with min less than 60, so if we change the interval, it will continue to work. Min less than 60, min plus plus. And let's go ahead and write our hours and minutes out. So C# format leading zeros, because I want the minutes to have their leading zeros. I need to just go and eyeball this. Refresh my memory. I'm going to forget about the leading zeros. Oh, no, you can do it like that. Colon D8 would print it out as an integer, pad it out to 8 zeros. So the 0 is the number to place, placeholder. The 22 is the width of it. And then when you specify the width of it, you can also specify the data type and that you want leading zeros. How many leading zeros can be specified there. That's pretty flexible. That's more flexible than Java is. See if I can keep that in my memory long enough. 0, 22, colon. Okay, so COW tab, or no, it's just CW, sorry. CW tab. And I want it to say something like 01 o'clock and 02 o'clock and 03 o'clock. So I'm definitely going to need a placeholder. The first placeholder is 0. Cheat, comma, and then the width of it. So 0, 2, colon. And then to specify the format, we're going to put D2 there, meaning that it's an integer and it's 2 characters wide. I always wish D meant double there, but it doesn't. Seems like I should be for integers. Okay, so that's going to take care of the hour. So close our placeholder and put a colon. Wait. Why did I put an end quote there? No end quote, but close our curly brace and then a colon and then open our curly brace, and this is the second placeholder. So curly brace 1. It also needs to be 2 spaces long, right? Because we have minutes, 00, 59, whatever. So 0, 2, colon, it's also a decimal, and we also want leading zeros padded out to 2. We could take that second part off and we could see the output and we would find that it's not as pleasing as we would hope. So curly brace, close curly brace at that point, end quote, comma, and then our 2 values that we're going to pass to those placeholders. Hour, comma, min. So this is the inner loop. It's a nested loop. We can tell it's the inner loop. This is the outer loop. While I'm thinking about it, I'm going to add end main there, just so. All right, so now when I'm running, what we're going to see is that for every one iteration of the outer loop, the inner loop is going to continue completely. It's going to iterate completely. It's going to count all the way. And I didn't put my console.out.write line at the bottom. CW tab, parentheses quote, press enter, and quote in parentheses, console.read line or read key, whichever you prefer. There we go. And we see it going, but I goofed up. It didn't go up every 15 minutes like I had planned on. Now here's a stupid fix for it. If, parentheses, min mod 15 equals 0. That would give me the output, but it's not really what I want to do. Right, so 1 o'clock, 1:15, 1:30, 1:45, 2. Gives me the right output. What are we doing? Well, if we divide it by 15 and we get a remainder, then it's not on one of those even points. It's not on 0 or 15 or 30 or 45. I'm going to take the if statement out, although that's a perfectly valid way of doing it, and change it so that we add 15 minutes to it each time. So instead of min plus plus, min plus equals 15. And there we go. Right, so for the first number is the outer loop counter variable. The second number is the inner loop control variable. So 0, 0, 15, 30, 45, and then the outer loop gets to increment once. So the inner loop runs through all of its iterations, and then the outer loop is allowed to go once. And it keeps doing that. Another classic example of that is printing out a bunch of asterisks to make a rectangle or a triangle or something like that. So like here where we printed a line with 50 plus signs, we had one for loop. Well, if we printed 50 plus signs and then went to the next line and printed 50 more and then printed 50 more, or something like that, let's print a triangle out instead of a rectangle. So our outer loop variable is going to be the row, right? Because we're going to draw the row one at a time, and then for each row, the inner loop is going to be controlled by the column, dictating how many asterisks we print out. So, int for parentheses int row equals 0, row is less than 10, semicolon, row plus plus, open curly brace, for int call equals 0, call less than or equal to row. That's what's going to make it a triangle. Rather than making it call less than or equal to 10, which would print a 10 by 10 rectangle, I'm just going to set it less than a row number. So that on the first row, it'll print out 1. And on the second one, it's going to iterate twice, so we'll see 2 asterisks. And on the third one, we'll see 3, and so far. So this is our inner loop. I don't really care if we put a curly brace or not in it. CW, tab, tab. Except don't make it right line, just make it right. We don't want to go to the next line. Just to be interesting, I'm going to print out hashes rather than asterisks. Once the for loop is complete, then we want to go to the next line. Right? Just like type, 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 type over and over and over, and you finally hit the enter key. Then CW, tab, tab, console right line. Something's bugging me this big time about my notes. Did I say that something was COW? Did I have that abbreviation anywhere? No. But what am I remembering? Yeah, right there. It's not console.out.WriteLine. It's just console right line. Right? Or we could just call it right line. That'd be pretty clear. Got Java in my head there. Alright, so now when it runs, the first row is going to print 1 hash. The second row is going to print 2, all the way out until the 10th row is done.
So would it increment columns?
Yeah, I forgot to increment anything. And so it's yelling at me about the syntax. So call equals 0, call less than or equal to row. Thank you. Call plus plus. And there we go. There's our triangle. What if we wanted it to be a rectangle? Then we would not go out to the row number. We'd just hard code a value there, like 10. Then it'd be a rectangle. Like that. I think it's kind of interesting having it be a triangle. But whatever. You get the idea. This is a nested loop. The inner loop, printing out every character in the row, that has to complete before it'll print the carriage return to go to the next row. And then the outer loop can increment once to go to the next row, and then it'll repeat again. So flowchart of a nested loop. Nested just means, tabbed over. We have an outer loop and we have an inner loop. You can nest anything inside of anything. This could be an if statement, and this could be a while, this could be a while, and this could be a for, this could be a do, and this could be an if, whatever. In this particular case, it's showing some kind of loop here, and then another loop here. And we can guess that there are not do loops because there are no bodies being executed before the test, only afterwards. So these are either while loops or for loops. And their example of a nested loop is to calculate some kind of interest rate over a while. I don't see any reason for us to do that since we've already got our example going. But it'd work like that. The interest rate is 4%. After 1 year, the bank balance is that. After 2 years, the bank balance is that. After 3, it's that. After 4 is that. I don't know if I quite agree with what it's doing. because it doesn't look like it's using a compound interest formula. But whatever, it's just adding the interest rate to it each time to it, which should give you the same amount, give you the same result. But for some reason when I've coded it, I've had slight differences. So, and then once the inner loop is done, then it goes and it sets a new bank balance. No, it doesn't. It starts at the same bank balance, but then we go for 6% rather than 4. Why do we start the same bank balance? We're going for interest rates, not starting balances. If we had incremented the starting balance, it would be a doubly nested loop. We'd have 3 loops. So instead, the outer loop is the interest rate, the inner loop is the year, and we see that here. The outer loop is the interest rate, and then the inner loop is the year, so it counts the years 1 through 5, and then the outer loop increments the interest rate one time, and we count through 1 through 5 years again, and then we count 1 through 5 years one final time. So accumulating totals. You just stick an accumulator variable above the loop, and then you can add stuff to it inside the loop. And you better assign it a value, or else it's got garbage in it. It's got an unknown value. And so the C# compiler will flag that as an error and not allow us to do that. So I am curious about how many asterisks or how many pound signs there are in our triangle. So I'm going to declare a variable called count. It's the count of the pound signs. I'm going to initialize it to 0, and then inside the body of the loop, now that I need more than one statement inside the body of the loop, I have to put my curly braces there. So I'm going to put a curly brace before and after that right pound sign, or that right hash. And also, along with that writing, I'm going to increment the counter. So count plus plus. Once the loop is done, I can display, print it out, and we'll know how many hashes we printed. And so it's kind of a summation thing. 1 hash, 2 hash, 3, 4, 5, 6, 7, 8, 9, and 10. So I believe it's going to be 55. That's a classic summation thing. The summation of 10, I believe, is 55. 1 plus 2 plus 3 plus 4 plus 5, all the way out to 10. Well, let's find out. CW, tab. We're going to write, quote, number of hashes or pounds equals, end quote, plus count. So you don't always have to use a placeholder. If you're doing something similar like that, if you use the plus sign, it'll just concatenate that numeric variable to the string that's being displayed. And in fact, if we counted them all, yes, there would be 55 pound signs being printed out. Normally you're adding stuff together, right? You're going to ask for the test scores and you're going to accumulate them all. You know, we did a problem like that where we asked for 5 test scores and we allowed the user to enter them, and then we added them up. That was a homework assignment a while back. You could do the same thing with a loop. So double total equals 0. And it sounds like a definite loop to me, right? We want exactly 5 test scores. So 4 parentheses int I for iterator, x for x equals 0, x is less than 5, or why don't we start at 1 and go less than or equal 5 so that we can print enter test score 1, enter test score 2, and so on. So x equals 1, semicolon, x less than or equal 5, semicolon, x plus plus, in parentheses. Let's write out a message telling them to enter the score. I'm just going to use console.write rather than write lines so that they'll enter their input on the same line. Console.W write, parentheses, quote, enter score number, and then I need a placeholder. So curly brace is 0, end curly brace, colon, space, end quote, comma, X. Then we need to let them type it in, and we need to add it to the total. So double score equals convert dot to int 32 parentheses in parentheses semicolon, and in here we're going to use a console.readline. Console.readline. Is this the best way to do it? Well, not necessarily, because it'll blow up if they type in some garbage, right? Ooh, I'm getting a syntax error. What's wrong with this?
Not enough parentheses.
Oh, I don't have enough opening. I don't have a curly brace, opening curly brace there. Good, thank you. What would be nice is if we added a method that would loop until they gave us some good input. We could do that, but for now, let's just go ahead and run this. And we can print out the total. No, we can't. What have I done wrong? I haven't added the total. I got the score, but I never added it. Total plus equals score. If this was all we were going to do, we didn't even need to declare the temporary variable. We could have just said total. We could have replaced this and said total plus equals, and then the rest of it. But it's nice to put it in a variable before we add it, in my opinion, because you can do some checks, right? You can make sure that they did not enter an invalid value. Now let's print out the total. CW, tab, tab, total of scores equals curly brace 0 end curly brace, end quote, comma, total, in parentheses, semicolon. And great, now we have input, so every single time we run our program, we're going to have to type in 5 values. We might change that to 3 or something like that. My scores are 10, 20, 10, 30, and 15. And my total is 85. We could calculate the average. You know how to do that as well. Just divide it by the number of scores that were entered. If you didn't know how many scores were going to be entered, if this is a while loop and it was an indefinite loop, you better create a counter that'll track it. Track how many scores they entered. Okay, I do want to play with that idea. I want to take this and I want to write a method instead. That'll loop until we get some good input. So I want that to look like this. Double underscore or double space score equals get underscore double parentheses and parentheses semicolon. This is going to be a function we're going to write. And it's going to fail if they give us some bad data. Well, we haven't written that method yet. We're going to come down here and do so. So underneath this curly brace way down here, after end main, but before the end of the namespace, before the end of the class, we're going to put it right there. Needs to be declared of type double, so it can return a double. Double space, its function name is get underscore double. In parentheses, in parentheses. Open curly brace. Let's write the simplest version first. One that just lets them type in something just like we did here. No capitals. String space S equals open quote, close quote, semicolon, S equals console dot readline, parentheses in parentheses, and then let's convert it to an int. Oh, let's go ahead and do it correctly. So we're going to need a Boolean variable to determine if it's correct or not. So bool space OK equals false, semicolon. Now let's call try parse. We need a variable to return. So double D equals 0. Now we've got all of our variables declared and filled in. They've typed in a value for S. We're going to call try parse. So OK, whoopsie, not double. OK equals double dot try parse, capital T, capital P, parentheses, quote. Let's pass in the string that they typed in, comma, out space D. Our output argument is the D variable. And then we can return D. Now this does everything except loop. But it's not going to be hard to modify it with a loop. So in advance of modifying it with a loop, or I guess we could go ahead and do so here. Do this. While, parentheses, not, exclamation mark, okay, in parentheses. Open brace, get rid of that closed brace and put it underneath the okay equals double. After that okay is equal to double, put the closed curly brace. And if it's not okay, we need to print an error message. So if parentheses not okay in parentheses, open curly brace, let's yell at them. I want to move this read line down inside the while loop so that I don't have to have it twice in the code. So I'm going to cut it and paste it above that try parse. Goodbye. Paste, hello. So if it's not okay, we need to display an error. Console, CW tab, non-numeric input not allowed, end quote, in parentheses, semicolon. And let's do a write so that they have a place to type. Right. We don't know what we're asking for anymore, but let's ask for a number. So console.write, capital W, parentheses, enter a number, colon, space, end quote, in parentheses, semicolon. And that's our loop. It'll continue to loop until they give us some good data. Can I get this all on one screen at the same time? That'd be nice.
Continue to loop okay because you either way because you don't make it okay ever.
Okay, I'm so sorry. Pardon me.
It's going to keep looping anyways because we haven't told it to make it okay if they put in a good input.
Is that true? Oh, I forgot to make it static, and we're inside a static context because main is static. So I need to make this static as well. You may be totally right. I'm just not seeing it yet. So static, double get double. Had to add that. Now it should compile. Inner score number 1. Let's make sure it works valid. Now let's see if it works for invalid. Okay, to me it looks like it's working right. So let me come over to your code and see. Point out where you thought it wasn't. Okay, so if you write a loop like this, you can use that over and over and over inside your code. And so if I ever ask you to write code that, loops until you get good input, you don't have to loop on every piece of input, right? You don't have to write, a while loop and then another while loop and then a third while loop and a fourth and a fifth. What might make this one nice is if we ask how many scores we're going to enter. And now if I give y'all a homework assignment of asking how many scores to enter, one person already did that for the last one, so it's going to be a real snoozer for you this time. But not that many people did. So what we're going to do is our homework's going to be based upon this. Write a program that asks the user how many scores to enter. It lets the user enter that many scores. It calculates the total and the average. So, pretty basic stuff, hopefully not too rigorous. Feel free to use this code here, you just have to make a couple of changes. I'd kind of like for you to loop and not allow failures. So I'd kind of like for you to use the get double method we wrote. Or another way. So use the get double method we wrote, or implement another way of ensuring the program does not stop if they enter bad data. Bad input. All right. So that may be a real quick assignment for you, especially if you take the code that we've already written. It would probably take you only like 5 minutes to add it. And if you want to start over from scratch, just for the learning, that's cool. To me, this is a pretty important concept here, this get double concept. I would like for y'all to have that committed to memory. Just the idea of looping until they get you something good. You can modify this even further to allow the passing in of a string, you know, to ask the question, so that instead of saying enter a number, it would print out some message. But we'll work on that another time. All right, let's go ahead and stop.